Hello everyone. Let us find out what is the instrument transformers. In a power system, we know that we are handling the higher amount of voltage and the current. And if we want to measure that voltage and current with our simple instruments that we are using in our labs, that is impossible to measure that higher amount of voltage and current. So what we are doing? For that, if we want to measure that voltage and current, we are using the transformers in conjunction with that instruments, and that is known as the instrument transformers. So whatever with the transformers which we are using in addition with that instruments, that is nothing but your voltmeter and ammeter. So that transformers are known as the instrument transformers. What is this instrument transformers will do? It will extend the range of that complete meters. That means that the higher amount of voltage and current can be measured by this voltmeters and ammeters whose range is very low. So here this instrument transformer can extend its range also, and it will isolate the complete instrument from that high voltage line also. So these are the two purposes of this instrument transformers. These instrument transformers, basically there will be the two types: current transformers and the potential transformers. Current transformers are used to measure the current. It is denoted by CT, and the potential transformers is used to measure the voltage. It is denoted by PT. So let us see one by one about current transformer and the potential transformer. First of all, let us see about the current transformer. What this current transformer were? Here, this current transformer, on its secondary side, it will produce the low amount of current. That means on the secondary side, the ammeter is connected, and the primary side, it is directly connected to the main supply or the main line. So on the secondary side, the ammeter is connected, which is of very low range, and due to this current transformers, the amount of current will get lower down on its secondary side. So whatever the current flowing on this secondary side, that current is directly proportional to your primary side current. This is nothing but your circuit diagram. Here you can see this is your current transformer's primary winding, and this is your secondary winding. So this primary winding is directly connected to the main supply here, and on the secondary winding the ammeter is connected here. This is nothing but your ammeter. So the value of current which is flowing on the secondary side, it is lower as compared to the primary side, but it is proportional to your primary side current, because the secondary side current depends on your primary side current. Whatever be the current which is flowing on the primary side, depending on that only on the secondary side the current is flowing. So here in this primary and secondary side, the coils will be there. So for the primary coil, you can see this primary coil, it is having 1 or 2 turns. So the number of turns on this primary side is very low. But as it is directly connected to your main supply here, that means it will carry the large amount of current. So therefore the winding or the coil, it is made up of thick wire, and it is always connected in series with the line. And on the secondary side, you can see the coil is having more number of turns here, but the amount of current which is flowing, it is very low. So it is made up of fine wire, or you can say the very thin wire. And on the secondary side, the ammeter is connected. On the secondary coil, the ammeter is connected here. So this is all about the primary and the secondary coil. So in the current transformers, the primary winding is very less as compared to your secondary side winding. The primary side winding, it is connected in series with the complete main line, you can say, and on the secondary side the ammeter is connected here. This primary side coil, it is made up of thick wire, and the secondary side coil, it is made up of very thin wire. So the higher amount of current, it is flowing in this main line, and depending on that, this ammeter will show the reading on the secondary side, because the current which is flowing on the secondary side, it is directly proportional to your primary side current. So in this way we can measure the higher amount of current which is flowing in the complete network with the help of these simple instrument. And with the instrument which we are using here, or the transformer which will do this thing, that is nothing but your current transformer. Now next, that is your potential transformer. Here what is potential transformer will do? The higher amount of voltage which is flowing in the network, or which is there in the complete network, that amount of voltage will get stepped down here. So therefore it is also known as the step down transformer. Here the voltage can be easily measured with the low range voltmeter. Whatever be the voltmeter we are connecting here, in conjunction with that we are connecting the potential transformer, so that higher amount of voltage can be measured with the help of low range voltmeter, which we are using in your labs. So it is also known as the step down transformer, because here the voltage levels are stepped down. In the primary side the voltage is higher, and on the secondary side the voltage is lower. So it is also known as the step down transformer. The circuit diagram will be like this. This is your primary side and this is your secondary side. The voltmeter is connected on your secondary side. Here you can see the number of turns on this primary side winding, it is more as compared to the secondary side winding. So here the number of windings on the primary side will be more, and on the secondary side the windings will be there, that is very few as compared to your primary side. On this secondary side you can see the voltmeter is connected here, and up to what range of voltage that will be shown, that is up to 150 volts. Standard, that is nothing but your 110 volts, but up to 150 volts we can measure the voltage here. So here we can conclude that with the help of this current transformer and the potential transformer, the higher amount of voltage and current will get stepped down to the lower value, so that our instruments can directly measure the higher amount of voltage which is flowing in the complete network, that is nothing but your voltage and current. So the current transformer, it is used to measure the current, and the potential transformer, it is used to measure the voltage. So in this way we can use this instrument transformer, that is a current transformer and the potential transformer, to measure the higher amount of voltage and the current which is flowing in the complete network. And in this CT, that is nothing but a current transformer, on the secondary side the current which is flowing, it is up to 5 amperes, and in the potential transformer on the secondary side the voltage which is there, that is nothing but up to 150 volts.